All right, everybody, so here's the 8.4 solutions video. Again, if there's any questions that don't get cleared up by the work we do, feel free to bring it up in class. All right, so first thing we're going to do, we're going to find our domain like we have been. So I've factored what's inside my radical and made my sign pattern of it, knowing that where the sign pattern is positive is where I'm going to have my domain. Make that look a little bit more like a parentheses. And that's also gotten me my zeros. If I were to try and plug 0 into what's inside my square root, I would end up with -5, which is not possible, so I know I do not have a y-intercept. Another giveaway is that where x equals 0 was on our sign pattern was negative. I already know that the zeros of my function are going to be critical values, but I also then need to take my derivative, set the numerator equal to 0, and check that value. And in this case, the value does not fit in my domain, so it technically, didn't mean to erase that, it technically is not a critical value. I know that what were zeros of my original function become vertical asymptotes on my derivative, and so I make my sign pattern for the derivative, knowing that I can ignore what's happening in between -1 and 5. I see that to the right of 5, my function will increase. To the left of -1, my function is decreasing. And I'm able to sketch my graph. Don't forget, it's a technicality and can be very frustrating, that our zeros are always going to be an absolute minimum or an absolute maximum. If it's a positive square root like the one we have, our 0 is going to be an absolute minimum. And then I'm able to give my range. Number 4, same thing. I set up what's inside my radical so that I can find my zeros, knowing that my zeros are also going to be critical values. Make my sign pattern of what's inside the radical, what's called the radicand, and I see that the only place that's positive is in between -3/2 and 3/2. As I've told you in class, if our domain has a defined start and a defined end, we can guarantee there's going to be a critical value somewhere in the middle. If I were to plug 0 in, I get a y-intercept of -3, which you could always write as y equals -3. I take my derivative, set what's inside my what's in the numerator equal to 0, and in this case it checks out 0 is in the domain. I can ignore to the left of -3/2 and to the right of 3/2, knowing that zeros of the original become vertical asymptotes of the derivative, and my function will decrease, then increase. Recognizing that I've got this negative in front of my square root tells me that my entire function is going to be beneath my x-axis, and also tells me that 0 is an absolute max this time. -3, what I get from plugging in 0 to my original function, is going to be my absolute minimum, and I'm able to give my range. All right, number 5. Again, I go through my process of getting my domain. I take what's inside the radical, set it equal to 0, factor and solve, knowing that the 2 zeros I get will also be critical values. Take my derivative, set what's in the numerator equal to 0, and this time what I get does fit in my domain. Looks like my sign pattern for my derivative got erased. So I know that I can make a sign pattern for my derivative, knowing that zeros of the original function become vertical asymptotes of my derivative. I get to ignore where my domain does not exist, and I would find that my function increases, then decreases. Plug 0 in to find our y-intercept. I know the zeros of my original function are critical values, and then the 0 of the derivative that fit in the domain. Since this was a positive square root, I know that 0 will be an absolute minimum. And then looking at my graph, plugging in -2, I would get a y value of 9. So I know an absolute max of 9, and I have my domain. My range. 9, going to require a little bit more work from us. Again, we see that we've got a negative outside the radical, so we're going to expect that any zeros are going to be the location of absolute maxes. I need to find my zeros as well as my vertical asymptotes. Zeros come from the numerator, vertical asymptotes come from the denominator. I make my sign pattern, again, of what's inside my radical and focus on where it is positive. Careful not to put brackets on vertical asymptotes when you give your domain, but to put brackets on your zeros in the domain. I can see that part of my domain has a defined beginning and end, so I'm going to expect to find a critical value in that space. Taking the derivative can be a little bit tedious in these ones. I simplified just a little bit, and now I've got my derivative. Set my numerator equal to 0. The value I get checks out, it fits in the domain. And of course, we know that anything that was a 0 of the original function becomes a vertical asymptote of the derivative. All right. So I give my domain, again, careful not to include my vertical asymptotes. I give my zeros. If I plug 0 into the original function, I would get a y-intercept of 1/2. My vertical asymptotes. My horizontal asymptote comes from addressing the lead terms in my function, so I know that I would have focused on the square root of x squared over x squared. Don't forget there was a negative in front of that square root, which is going to reduce to negative square root of 1, and that's going to lead me to a horizontal asymptote at -1. I know that I've got an absolute max at y equals 0, that is y equals 0, I should say. If I plug 0 in, my y-intercept becomes my relative minimum because my graph goes down forever. I'm able to give my domain. I don't cross my horizontal asymptote, so I see that my horizontal asymptote is going to break up my domain. Starts over at -1/2. Notice that is the y-intercept, so that's why it's in a bracket, and ends at 0. And so that is in a bracket. All right, the multiple choice problem is worth talking about together in class, so we'll save that for class because I want to be able to show you the graphs as we answer the question. All right, again, if you have any questions, please feel free to bring it up in class, and we'll continue working.